Okay, volumes of revolution, and something that was covered in Math 121. Certainly we want to review certain topics. The main reason just to jog your memory on what you have to be able to do, which is simple differentiation, simple integrations, and be able to apply those to certain topics that were covered. And one was taking a region, and there's a good example here. It's a simple one. We're going to take this region between 0 and 1. Well, I do see a picture drawn here, and what's this going to be? This is the root of x over here, and this is the region between 0 and 1, right? That's the region. What do they want to do? They want to rotate it about the x-axis. So it's an indication over here of rotating it about the x-axis. What do? We take a representative rectangle. Let me just get my red pen out here. We take a representative rectangle like this over here. And the problem now is being able to visualize what happens when you rotate this thing about the x-axis. And we're hoping that you can, I'm not saying draw great pictures, but, see something like this over here that looks like a disc, right? And the volume of a disc is fairly easy to deal with. I'm going to put that down over here now. And the volume of a disc is going to be the thickness of the disc. Well, in this case over here, it's delta x. And this is going to be the volume of the disc, by the way. So you are going to get delta x over here. Then the question is, what's the surface area of that? And that would be pi r squared. However, someone's going to say, you can't have, you're mixing concepts over here with an r and an x. We'd like to get everything in terms of x's over here. So what's nice about this over here, the height of this thing is really the y coordinate, and the y is just simply equal to the root of x. So you'd write that down. All right? So the volume of one of those disks, by the way, depending on where x is, would just simply be pi x delta x. Now what are we going to do? We're going to add a bunch of disks together, starting at 0 and moving up to 1. That's going to be an integration problem. Let's write that down. So the volume is going to be a sum of all those disks from 0 to 1, and those disks are worth this over here, pi x, and that delta x, we're going to put the differential down, dx. Can I do that integration? It looks like a really simple integration, by the way. What are you going to get? Pi x squared over 2, limit integration 0 to 1. Plug in, what do you get? Really something pretty simple, pi over 2. All right? Again, we provide a key for you. The key is over. Whoops, sorry about that. We provide a key for you. The reason we want to provide a key for you, we'd like you to look at it. All right? We'd like you to look at the integrals we set up and the answers we're putting down. All right? Now, certainly we'll go through more examples, but this is a review of what you learned in Math 121 or Calc 1. Thank you.